Our next way to solve systems is with elimination. With elimination, we're looking for variables to be on the same side of the equal sign, and we want our x's and y's to line up. Okay, variables on the same side of the equal sign, and we want our x's and y's, or our variables, to line up with each other. Okay, the other thing that we're looking for is we want x or y to have the same number opposite sign. That's really important. Okay, same number, opposite sign. Same number, opposite sign. X or y. One of the variables has to have the same number, opposite sign. Okay, so let's look at one. If we look at number 1, the first thing we want to look for is, are the x's and y's on the same side of the equal sign? Well, here's the equal sign. For the first one, x and y is over here. For the second one, x and y is also over there. So we're good. Okay, now we need to look at our numbers. Remember, the number in front of x or y has to have the same number opposite sign. Do the x's or y's have that? Well, the x's have 4 and 2. Those aren't the same number or opposite sign. So let's look at the y's. The first y is 3y. The second y is negative 3y. Those have the same number opposite sign. Once you get the same number opposite sign, what we're going to do is add the equations together. Let's see what happens. 4x plus 2x is 6x. And then what happens when I add my y's? 3y plus negative 3y, they cancel, or they eliminate. They become 0. They're gone. Equals 16 plus 8 would be 24. And now we're down to an equation with one variable. So we can go ahead and divide and get our solution for x. Now, just like our other ways to solve systems, we do have to have an x and y. We have to solve for both variables in the equation. Does it matter which equation you plug that back into? No. Why? Because we're solving for the point where these two equations meet, which means the point for our solution is going to be a solution to both equations. I'm going to plug it into the smaller numbers, which is the second one. So we have 2 times, I have an x equals 4, so I'm going to plug that 4 in for x, minus 3y equals 8. What's that give me when I solve it down for y? 2 times 4 is 8. I'm going to get my y alone. I have a positive 8, so I'm going to subtract 8 to the other side to get negative 3y equals 0. Divide by negative 3, so y is 0, which means these two lines intersect at the point 4, 0. Let's look at another one. Now, if we look at number 2, what's wrong with this problem? If I look at the first equation, x and y are on the same side. If I look at the second equation, they're not on the same side. So I need to rearrange to get them on the same side. Well, the easiest way to do that would be to add 5x to the other side. So we only have one step here. So we'd have 2y plus 5x equals 12. Now, bring down the first equation. Make sure you are lining up the x's and the y's. So I just wrote the y first, which means my y from my first equation also has to be written first. Then I have my x. So I'm going to write my x next equals the solution, or the answer, okay? That's on the other side of the equal sign. Now we're going to look at our new equations. So we can totally ignore these for right now. And we're going to look at these new equations that are lined up. Look at your x's and y's. Do either of them have the same number out in front? Yes, the y's. Are they the opposite sign? No, they're not. That's a problem. How do we get them, if we added them together, how do we get them to cross out or become 0? Well, they'd have to have the opposite signs. What would you multiply by to make them have the opposite signs? You're going to multiply by -1. Now, when you multiply by -1, you can not only multiply the y, you have to multiply the entire equation. We have to change the whole equation so that we're keeping essentially the same equation, we're just manipulating it. If we didn't do that, we'd be changing the equation and we wouldn't get the right answer. So what I'm going to do is I'm going to write the first equation exactly how it is off to the side. And now I'm going to multiply everything by -1 in the second one. So -1 times 2 is -2y. -1 times 3 is -3x. And then -1 times 8 would be equals -8. Now if I look at my y's, I have the same number, opposite sign. So at this point, I can go ahead and add my equations together just like we did on the first one. 2 plus -2 is gone. They eliminate, they cancel. 5 plus -3 would be 2x. 12 plus -8 is 4. Now I'm down to one variable, so I can go ahead and solve. So I'm going to divide by 2 to get x equals 2. Remember, that's only my x. Now, you can go back and plug in to either of the first equations, or you can plug them into the ones that we kind of manipulated and changed. You will get the exact same answer no matter what you use. I'm actually going to use this equation right here, one of the originals, because y is almost solved for. So I have 2y equals 12 minus 5 times 2. I'm going to solve that down for y. So 12 minus 5 times 2 is 10. So I have 2y equals 2. I'm going to divide both sides by 2 to get y equals 1. So these two original equations would meet at the point 2, 1. And that's your solution. What happens on the next one? Let's look at this guy. Take a second, see if you, actually let's do this one. Take a second, see if you can do this one. All right, so what are we looking for? We're looking to see if the x's or y's have the same number, opposite sign. Well, my x's have the same number. Do they have the opposite sign? Nope. So let's look at the y's. They have this, they have the same number and they have the opposite signs, which means we can go ahead and add these equations together to eliminate. X plus x would be 2x. 3 plus -3, eliminate, they cancel. 6 plus 12 would be 18. Go ahead and solve down that one variable equation, so x equals 9. Now that I have my x, I'm going to have to find my y. It does not matter which equation you use to plug it in. I'm going to use my first one just because. So we have 9 plus 3y equals 6. I replace the x with the 9. Now I'm going to solve it. So I'm going to subtract 9 to get that y alone. So I have 3y equals 6 minus 9 is -3. Watch those negatives. Divide by 3 and y equals -1, which means this system meet at 9, -1. Okay, go ahead and try this next one. All right, so on this one, my x's are a mess. Those aren't the same number, but they are the opposite sign. But if I look at my x's, they're at least the same number. So how would I get them to be opposite signs? I would multiply one of the equations by -1. Does it matter which equation you multiply? Nope. So if you didn't do exactly what I do, that's okay. I'm going to multiply my first equation on this one by -1. So when I multiply that through, I have -1 times x is -x. -1 times -3 would be plus 3y. And don't forget that last number. Now this one doesn't matter because -1 times 0 is 0, but it does make a big difference when it's not 0. Now I'm going to bring my second equation over exactly how it is. Now I can see that my x's, they line up, they have the opposite sign, and they have the same number. So I'm going to go ahead and add my equations together. -x plus x, eliminate, they cancel. 3 plus 10 would be 13y. 0 plus 13 would also be 13. Now I'm down to one variable, so I'm going to go ahead and solve for it. This one's a one-stepper. We can just divide by 13 to get y equals 1. Now that I have my y, I need to solve for my x. Doesn't matter which one you plug into. I'm going to use the second one. So I have x plus 10 times y equals 1, so I'm going to replace the y with 1, equals 13. 10 times 1 is 10, so I have x plus 10 equals 13. I'm going to go ahead and solve down for x by subtracting by 10 to get x equals 3, which means these two equations intersect at 3, 1.